Hello students, let us start our discussion about Earth's magnetism and terrestrial magnetism. So, as we know that when we place or freely suspended a bar magnet by putting it a massless thread, then it always tends or aligns in the direction of north and south. So, it always stayed in north-south direction. It means Earth always possesses a magnetic field and applied some force on this bar magnet to stay it in this position. So what causes the Earth possess a magnetic field? In ancient time it was thought that there is a giant magnet placed just along the axis of the Earth. So Earth possesses a magnetic field, but this fact was totally wrong. And in today's sense, today's concept said that there is a convectional current flowing through the core and the mantle, because we know that there is a molten stage of the nickel and iron inside the Earth, deep side of the Earth. So when Earth rotates, then it also rotates in another form, but the highest temperature of the core, the high energetic particle from the interior of the core moves to the cooler part of the core. So liquid iron and nickel particle moves from higher temperature part to the lower temperature part, and then after cooling they come back to this. So they form a convectional current during its motion, and this motion of the molten stage of nickel and iron forms a magnetic field due to the flow of this electric current. So this phenomena is thought as the dynamo effect. So as we know that by experiment it is observed that if we freely suspended a bar magnet, then its north pole always lies along the north direction and the south pole lies along the south direction. But in a bar magnet there is a magnetic field line emerging out from the north pole and entering into the south pole. But observations shows that Earth behaves just opposite phenomena. It means the magnetic field lines emerging out from the south pole and entering into the north pole. It means the north pole of the bar magnet behaves just like a south pole of a bar magnet, and the south pole of the Earth behaves like as a north pole of like this bar magnet. So let us come to know some different concept in respect to terrestrial magnetism. First is geographic axis. So what is the geographic axis? You are seeing that NG and NSG. This is the axis of the Earth about which Earth rotates. So it is a straight line passing through the geographical poles of the Earth. It is the axis of rotation of the Earth, and it is also known as polar axis. Now the second context is geographic meridian. You are seeing that in this figure, this is a geographic meridian plane and this one is the magnetic meridian plane. So what is geographic meridian plane? At any place it is a vertical plane passing through the geographic north and south poles of the Earth. Okay. Now geographic equator, it is the great circle on the surface of Earth in a plane perpendicular to the geographic axis. All the points on the geographic equator are at equal distance from the geographic poles. Okay, so this is a simple definition of the geographic equator, because we know that at every point on the equator, every point placed on the equator is equidistant from the poles. Okay, so this is the geographic equator. Now come to the fourth context, that is magnetic axis. You are seeing that the magnetic axis NM and SM makes some angle with the geographic axis, that is the rotating axis of the earth, that is equal to 11.3 degree. So we are saying that if we define the magnetic axis, then we get it is a straight line passing through the magnetic poles of the earth. It is inclined to geographic axis nearly of the earth. It is inclined to geographic axis nearly at an angle of 11.3 degree. Okay, now magnetic meridian, it is a vertical plane passing through the magnetic north and south poles of the earth. You are seeing that in this figure, this is the magnetic meridian and this one is the geographic meridian. The angle between the geographic meridian and the magnetic meridian is known as declination. We define it later. Now come to the last context, that is a magnetic equator. It is a great circle on the surface of the earth in a plane perpendicular to the magnetic axis. All the points on the magnetic equator are at equal distances from the magnetic poles. So these are the 6 important concepts related to the earth surface and earth magnetic field and geographic axis and geographic meridian related to earth. Now let us see, here is a angle, some angle made between the geographic meridian and the magnetic meridian. So this angle is known as the declination. As we know that it varies from place to place. If we go throughout the surface of the earth, then the angle of declination varies place to place. If we are seeing on the map and we find 2 lines on the map that possess same declination, then those lines are known as isogonic line. But if we took 2 lines which are not possessing same declination, they are known as agonic lines. Okay, similarly here you are seeing that the earth magnetic field component B, this is the resultant of the earth magnetic field. This one is the horizontal component of the earth magnetic field and this one is the vertical component of the earth magnetic field. So the angle made between the horizontal component of the earth magnetic field to the resultant of the earth magnetic field is known as dip or inclination. So this angle delta is defined as dip or inclination. If it is 0 at the equator and 90 degree at the poles, and if we draw 2 lines on the map, then if they possess same dip or inclination, then these 2 lines are known as isoclinic. But if we draw 2 lines and they are not possessing the same dip or inclination, then they are known as aclinic lines. So these are the basic properties related to the earth magnetism and terrestrial magnetism. Okay, so keep in mind all these basic concepts and understand in a better way by which you can easily express them and can understand or you can express about all these things in front of anyone and also write more easily in the examination. Okay, take care. Thank you.